sure that audio is working. And I have a quick update. We talked about that final week where we take the assessment and then have an in-person day. Natalie, who you met on day one, is going to consolidate on that Tuesday. Instead of having the in-person wrap-up day on Wednesday after our assessment, we'll just roll right into lunch after you finish your test. So if you want to hang around on that Tuesday, that's what we're going to do on the 29th. We have our assessment, then lunch, plus info about registration for fall, and whatever other questions that you want to run by Natalie's team and me that afternoon. So our assessment is 11:30 to 12:45. Lunch will start at 1. Natalie is planning programming of some sort through 4. You don't have to stay all afternoon. If you're not available, I would recommend just, taking advantage of the lunch. It will be served right away, and then sticking around as long as you can for whatever other information, as I think it will be of value. Now, the only thing that concerns me about this schedule is that that assessment time is our class time only, an hour and 15 minutes. So if you all are agreeable, I am going to change this to 11 meeting time. So you have 30 more minutes to assess on that day. Is that okay? So on July 29th, when we're scheduled to do our assessment, let's show up, start at 11 to give you a little more time, okay? Yeah, it was a little out of focus there, so that's what I was adjusting. All right, so let's talk about our stuff we want to do today. Remember, we were looking at Module 7. And so first up, I want to kind of revisit 7.5. We did not look at that section to review it. And then second, we will pick up from 8.3 moving forward, okay? So let's start with 7.5, which is about solving compound and absolute value inequalities. The word "and" requires that we find the intersection of the two solutions, and I'll show you an example. Or means we want the union of the two solutions. Now, if the absolute value inequality, as you see in the example there, is absolute value of stuff less than some number, then that means it's an "and" interpretation. If it is absolute value of stuff greater than some number, then we take the "or" interpretation. So let's look at the example. The example says the absolute value of 5 minus 4x greater than 9. Straight program there, I don't need that. So let's first classify it. This is greater than 9, you see here. So we're going to take the "or." When we set up our two equations, we treat them as one or the other can be satisfied. So remember, when we deal with absolute values, we break off into the first one and the second one to solve. With the second one, we set the right-hand side to the negative number. And if we're introducing that negative for an inequality, we switch this sign, similar to when we multiply by negative on both sides. So that's kind of as is, dropping the absolute value. Here, when we drop and introduce the negative, switch around the order of that sign. Next up, we're going to solve both of these. So that's going to involve moving this 5 so that it's paired with this 9. Right? So negative 4x greater than 4. Then we'll want to divide that 4 on both sides, that negative 4. Right? Divide it. Divide negative 4. And so we're dividing a negative on the inequality. That means we need to change this to this way. Then x is, that's going to produce a 1 negative. Positive divided by negative. So there's one of them. Now we'll solve this one. The operations are going to look similar. However, the numbers will turn out different because here negative 9 and negative 5 combine for negative 14. This looks similar. Divide negative 4. Number is going to be a little different in the end. We switch this sign again since we're dividing the negative. Then two negatives divide for a positive, 14 4. We could leave it like that or reduce it by 2 to 7 over 2. Okay? Then we want to sketch out what we found on a number line, negative 1. Kind of orient yourself with a 0 in the middle. Positive 7/2 somewhere over here. And let's sketch out less than negative 1. That's going to be coming this way. Greater than 7/2. That's that way. And so either or of those regions. Now this is a little tricky because we have two separate regions. How do we write that in interval notation? Well, recall this is not equal to bar here. Then going this way would be negative infinity. Also not equal bar here, so we use paren. We go up to positive infinity. So, all told, we're going to take combination of these two intervals, negative infinity to 1, negative 1, union 7/2 up to positive infinity. There's our solution. That interval notation, if you look back at the top, it says or requires finding the union, and that's what that symbol means, the union of those two intervals. I'm going to pause for just a second because I know that's a lot to take in. Sharita, we talked about earlier, we're going to combine the 30th with the 29th. If you can make it by 11 to give yourself plenty of time for the assessment, we're going to end it at the regular class time, and then lunch will start at 1. So really you could go all the way to 1 testing if you need it. But if you come in 11, that'll give you a little more time on that day. Remember last time I said I would hang around until 1:30 or whatever. Since Natalie wants to do lunch that day with information, you can stay as long as you want that day. But I want to offer starting earlier so you have more time on the test, okay? Yeah, instead of having lunch and information on Wednesday that week, we're going to just combine it all into Tuesday. Yeah. The lunch will follow immediately after our test, so I recommend you take advantage of that. And then if you need to go at any point, that's fine. But Natalie has planned like information about registration and other things up until 4 that day. Any questions on that first example of 7.5? You'll notice on the example right up that it says 3.5. That's the same as this. I would prefer you write it as fraction form, 7/2. Gonna leave those there for a reference. Yeah, kind of our review day, that Thursday next week, a week from now. Mhm. We'll do class on Tuesday next week and then class on Thursday. And what? Yeah, Thursday, we'll do as much review as possible during that class, and then you'll have the practice test that you can use as well. I'll show you how to access that. All right, let's look at number 2 on the actual, yeah. Let's go ahead and look at number 2 on 7.5. Absolute value for x minus 1 is greater than or equal to 12. We want to break it off just like we did over there. Number 1, just write it as is. Number 2, write it with negative on the other side, negative 12, and flip the sign that way. Then solve these. So we'll add 1 on both sides so that we're down to 4x greater than or equal to 13. And then we're going to divide that 4 next to the x. And that's going to give us x greater than or equal to 13/4. Over here, the operations are going to look similar, just numbers turn out different. For x less than or equal to negative 11. And after dividing 4 on both sides, we'll wind up with x less than or equal to negative 11/4. Now this, to start with, was greater than. Greater than means we take the or interpretation. So x needs to be greater than or equal to 13/4 or less than this amount. So similar to what we just saw, we have negative 11/4 over here, 13/4 over here. We can be greater than 13/4, less than negative 11/4. And then we have equal bars. That's the only difference. We didn't have equal bars over there. So that means we're going to use square brackets on the numbers when we have equal bars. And we're going out to negative and positive infinity, just like before. The structure of our intervals will be very similar, except we have that square bracket union. That is everything similar except for that. Square bracket there, go into positive infinity, close with paren. Okay. So I want you to recognize how the structure is similar in some ways. Numbers are different. Got a lot of structural components that can kind of be your guidepost in those 2 examples. I'll try to give you something to hang on to because I know it's a lot. Now, that last example, number 3, says 2 times absolute value of x minus 5 plus 3 less than 7. So notice the structure of that one doesn't quite match with what we started with here. We've got to have it in this form prior to breaking off into the 1 and 2 inequalities. So we got to get here first, then we'll break off. To get there, notice that right there is what we have to isolate, kind of like it's the variable. We have to get that by itself first. So let's look at what's going on around it. It's got 2 times it and plus 3's it, all right? So just like that were a variable, we're going to take that 3, move it away from it. Then we have 2 times it left, less than 4. And then just like that were a variable, 2 times it means we need to divide 2. Divide 2. So that 2 times it divides evenly, leaving us with absolute value x minus 5, less than, we get a 2 there. Now we're at this stage, at the start of this problem. Break off into 1 and 2. First one as is. Second one, take the negative of the other side and switch around the order of sign, greater than. Then let's come and solve each of these plus 5 on both sides here. Leaves us x less than 7 plus 5 here. Similar step, a different number, we get 3. And this puts less than. Less than means they need to be joined by and. Okay? And can x be less than 7 and greater than 3? Let's see. 3 and 7. Coming less than 7 is this way. Coming greater than 3 is this way. And when they meet up like that, then you're finding a good and region. 4, for example, is greater than 3. 4 is less than 7. 5, 6, 6.5. Stuff in that region satisfies one and the other. Is the idea? And so we have no equal bars up under. So that means, as far as our notation is concerned, so we're going to use paren on either side. 3 to 7 is our answer. A little bit a different structure there. Here, notice we could be over here or over here, and that looked this way. Here we have to be less than 7 and greater than 3, and that's this region in the middle. Right. Remember I said we were going to pick up from 8.3 in Module 8 after a little bit of looking at 7.5. Go back to 7, keep practicing. I know 7 is very complex, so keep practicing. Don't beat yourself up if you're not immediately getting everything right in Module 7. That one might take a little bit more practice over a 2 to 3 week period, for example. So just keep on working on that. And let's look at some more examples from Module 8. We got factoring trinomials coming up. Trinomials mean the three terms, like some number times x squared plus another number times x plus a constant number. That's an example of a trinomial. Now, if I give you trinomial, like example number 1, x squared minus 2x minus 15, and I ask you to factor it, then factor this trinomial. There's lots of different ways that people have developed kind of tricks and bags of tricks methods to factor trinomials. And I'll show you one that's popular based on my experience in previous semesters. The way I learned was you have to kind of restrict yourself by the first term, like that. 2x's multiply up to x squared. And then you look at the last term and write down factors of it, like 3 and 5. And then finally, you look to the middle term and try to create that -2 out of these. So -5 plus 3 would make -2. But that requires a lot of kind of dexterity and flexibility, confidence to just do it, boom, trial and error like that. So a popular method, if I can remember this, is if I want this number, I need to add to -2. I can do so by 3 and -5. I can't remember what goes on top of that cross. I'll have to look up this method after I get home. But you get the idea. Like this times this needs to give you this number, -15. And then whatever you decide here has to add to this number, -2. Okay. Maybe this is something like a 1, since that's what's going on here. 1. Notice how if I decided to throw it this way, -3 times 5 for -15, I would get +2 when added in. And that doesn't match my middle term. So when you add these down, make sure you get the correct sign here. If not, then change it. Make that positive, that negative, so that now when I add them, I get -2 to match that. Then drop down to your factors. You got 1x plus 3, 1x minus 5. What you take away from your cross product. We'll practice some more. Let's take the next example is 6x squared plus 11x minus 10. So the cross method has this times this on the top. 1 times -15 on the top. It has this on the bottom. And then it has things that multiply up to this here. Okay? Things that multiply up to this here. Things that add to this down here. So let's create the cross for this example. Up here on the top, we're going to have 6 times -10, which is -60. Down here on the bottom, we're going to have +11. Now, we need to think of factors of 60 that add to +11. What two factors add to +11? Well, I'm thinking of -6 times 10. That's just what I can think of for factors of 60 right away. But -6 plus 10 is 4, not 11. So what are some other factors of -60? Those are not working. Maybe take your calculator and divide like 3 or 2. Try other possibilities. And when I get around to multiplying or dividing 5 by divide 5, then I get -12. 5 plus -12, that's -7. If I change the sign, I put the negative on the 5 over here, I just get +7. So I don't get 11 in the middle, right? So, what? Okay. So we have a proposal. If those don't work, I'm trying -15 and 4. Those are factors that multiply up to -60. 4 plus -15 gives me -11. Almost there. What do I need to do? So switch around these signs, make the 15 positive, make the 4 negative. They still multiply up to -60, but add to +11 then. So that's good. Now, what do we do from there? Is the next question. Okay, we take 6x squared minus 4x plus 15x minus 10. So we break off these two parts of 11, essentially. Notice how this part of what we wrote maps back to what we started with. Those are equal. Right? We've just rewritten it in a different way. But what this allows us to do is to focus on two terms at once. And so we can say, okay, these first two terms both have 2 and x in common, right? So 2x can come out. 2 times 3 will get me to 6. And x times x will get me to x squared. Then I'll look at this term. What if I took 2x out of it? Then I'd need a 2. Huh? Then look at that next group. What do they have in common? 15x and 10, negative 10. What factor do they share? What is it? 5. And so I can take a 5 out of those. 5. And then I ask myself, what times 5 gives me this? 3. That has an x with it. Then a minus comes down. What times 5 gives me 10? 2. And look how that thing matches. So that means we can separate it off. So 3x minus 2 is common to both of these terms, one having 2x and the other plus 5. So I can reorganize it in that way. Factor off that thing that agrees and then bring together those things in the front. Notice how that matches this form. That's what we're shooting for. Paren with 2 things in the paren times another set of parens with 2 things in it. And thank you. Just looking at those two, why was this one more complicated, do you think? Like, when would you know to be this deliberate with these 2 pieces rather than just, boom, taking them in there? Do you notice any difference between those two and how they started? It's this thing. There's a 1 here. There's a not a 1, some other number in that leading term is what we call it. So if that's the case, then you have to do like a breakdown like this, and then this is called factor by grouping. Group the first 2 terms, group the second 2 terms, factor them separately, look for common things after you do that. If that's the case, then it's going to work. You organize it like that. Yeah. Let's try a few more of these. Looking at the practice problem, x squared plus 9x plus 20. Here, we have 1 times 20. For 20, we have 9 positive here. What times what gives us 22 times 10? That adds to 12. Right? That's not going to work. Give me some other factor. What multiplies to 20? A 4 and a 5. Okay, let's try that. 4 times 5 gives us 20. And they add to 9. That looks good. That looks really nice. So, since this is a simple one, we can just go directly to factor form. X plus 4 times x plus 5. And if you wanted to check this, you could do the FOIL method. First, inner, outer, Not too bad, huh? Another one, 2x squared plus 9x plus 10. Your second practice problem on the paper. Now this one has a 2 there, so we're going to have to be a little more careful. 2 times 10, that's 20. 9 in the middle. We already know the drill. 4 times 5 gives us 20. Adds to 9. But in this particular example, we can't just go straight to the answer. We need to write it out with these two things here. And then the original thing coming down. Yeah. So what we've done is we split this 9x into 4x plus 5x. Now let's group. These first two share a 2x, right? X times it will give me x squared. 2 times it will give me the 4x. Over here, we share a 5. X times it will give me that 5x. 2 times it will give me the 10. Now I have matching stuff here. Take it out and write what I have. Otherwise, 2x plus 5 out here. There we have final answer. Three y to the fourth, 21y to the third, and 30y squared. That one's a doozy. I look across all those terms and I see that they all have a 3, right? I also see that they all share at least a y squared. So like we were talking about on Tuesday with greatest common factor, take that out. That'll make our lives a lot easier. We're left with 2 y's on the first term, a 7y on the second term, because 3 times negative 7 gives us negative 21, and 2 y's times 1 y gives us 3. And then that last term needs a 10, for 3 times 10 for 30. Y squared is already represented, so just 10. Then I can focus my attention strictly here to continue factoring. So I'm going to bring this common factor that I have down, just so I don't forget it later. And then I'm going to focus my attention right here. I have 1 times 10 for 10. I've got a middle term of negative 7. And I've got to create negative 7 with factors of 10. 2 times 5 gives me what? Positive 7. So those are the factors I want. They just don't have the sign yet. How else can we multiply up to how else can we multiply up to positive 10? Negative 2 times negative 5. Those will add to negative 7. But sometimes you have to do introducing negatives on both. Now we're ready to go. Y minus 2 and y minus 5. We got a 1 here. So that's why we can jump directly to the factors. Remember, when it's simple, we can jump directly to the factors. We don't need to do the break-off method. We can do the break-off method. It's just going to result in that. Y squared minus 2y minus 5y plus 10, a group y times y minus 2 minus 5 times y minus 2. And so then I separate off the y minus 2 and left with y minus 5. You don't need to do that. I'm just showing you. If you did the deliberate break off, like we always do when there's a non-one term here, you get the same thing. That's the same. Different order, but same thing. So that's factoring trinomials, section 8.3. Something that takes a little bit of practice. Based on my experience, it's not something that is like quick. I know when I first learned this or tried to like figure it out, it took me a while. It took me like, I don't know, a week or more. Okay. So just give yourself the time and space to practice. Then you pretty much have all the tools you need to do things like you see in section 8.4. Factor completely. 8.4 basically the factor completely. You got some suggestions, look for common factors, like we did here. We found a common factor, 3y squared. Check to see if it's the difference of squares. We talked about that in 8.2. If it is, you can use that nice form. Difference of cubes, sum of cubes, perfect square trinomial, trial and error or grouping. Number 5, that's what we've been doing most because that's kind of like your fundamental fallback plan. Number 5 in that list where it says factor trinomials by trial and error or grouping, that's what we've been doing. That's your fundamental. You don't have to worry about number 4. Number 6, with 4 terms, factor by grouping. We've been doing that right here. That's factor by grouping. Those steps. Okay. So if you're looking at 4 terms, just look at the first 2, factor, look at the second 2, factor. That's called factoring by grouping. So let's just try the first practice problem from 8.4 is 12a squared b plus 3ab squared. What do those share? They share an A and a B, both of them. I'll take that. Anything else? And what? They're on the different letters there. The only thing I would advise that you kind of take account of there. What about the numerical components? Do they share factors? 12 and 3 both have a factor of 3, right? All right. Now, because this one only has one A and this one only has one B, that's why I was kind of stopping you from saying square on both of them. Take your lowest exponent from each time. Then write down what's left over. 3 times what gives me 12? 4. Do I need any more A's to represent this? Yes, 1. Do I need any more B's? No. And then next term. 3 times what gives me this? 1. Do I need any more A's? No. Any more B's? Yeah, 1. And then just as a final nod to what we have, you don't need to write 1 in front of a variable. Let's factor this by grouping. 3x cubed plus 9x squared minus 2x minus 6. Remember, grouping, you look for the first 2 terms, then the last 2 terms. First 2 terms share what? A 3, and how many x's? 2 at most. I need a 1 and what here? 1x. I need a what here? 3 times what gives me 9? 3. X squared already there. Okay. Now look at these. They share a minus 2, looks like. Times x gets me that. Times 3 gets me the 6. And you got some negative, some positive there for negative 6, negative. All right, these match. So we break them off and say 3x squared I have from here and minus 2 I have from here. So that's an example of factoring by grouping. We were doing that back here a little bit already. Okay, number 3 says factor this difference of cubes. This is similar to 8.2 when we factor difference of squares. Look at your form at the top. For when you have things cubed, and you have a cubed minus b cubed is a minus b. You see this? A squared plus ab plus b squared. Use that with whatever is 3 times itself here. That's 2x. 2x times 2x times 2x, that's 8x cubed. 3 times what gives me this? 3 times 3 times 3 gives me 27. So A is 2x, B is 3 in this case. And then I just use this form. And so this is A minus B, 2x minus 3. And then A squared, 2x squared, plus A times B plus C squared. And then I just need to clean up that second one a little bit by squaring those outer pieces. 2 times 2 for 4, x times x for x squared. This 2 times 3 for 6x, and then 3 times 3 there on the end for 9. I'm just using that plug-in kind of form on that number 3. Same thing for number 4. Just use your sum of cubes. And then that last one, number 5, 4y to the 5th minus 16y cubed. These share something, right? They share a 4 and at least 3y. I've already got my 4. How many y's do I need to get to this term? 2, right? 2 and 3 for 5. 4 times what gives me 16? 4, and I've already got all my y's. Notice that is a difference of squares, 8.2. difference of squares. And we had a formula for that. Bring this part down. Our formula for difference of squares with a equal to y and b equal to 2, square root of this and square root of this, is a minus b times a plus b. The difference of squares. If you don't use that formula, you could come out and use your fundamental. You've got 1 times negative 4 going on there, or negative 4. You've got no middle term here though, 0y. So what factors of negative 4 add up to 0, 2, and negative 2? 2 times negative 2 gives us negative 4, and then they add to 0. And notice that's what we used in our factors in the formula. For the last section of Module 8 is to solve with factoring. So we can use this stuff we've been practicing in the previous sections to solve equations. If we had, for example, x squared plus 4x equal 21, we would want to move this 21 over here, subtract it on both sides, so that 0 is on the right-hand side. That's important for when you're solving by factoring, that you have 0 on the other side. And we have x squared plus 4x minus 21 now over here on the left. We factor this. Okay. Factor, we got 1 times negative 21 for negative 21. Need to add to 4. What are my factors of 21? 3 times 7, I can think of. And which one should I make negative? Which one? Try it out. 3 plus negative 7, you get negative 4. Perfectly valid try, but I want positive 4, so I turn my negative sign over to this one. Negative 3 plus 7, that's positive 4. Okay. It's important to check yourself. Don't trust yourself all the time. You know, a failed try is a good one a lot of times, if you recognize it. Okay. Now we have x minus 3 and x plus 7. So we take from our diagram above. And then equal 0 now. We have an equation. If something times something equals 0, so long as one of them is 0, then we're good. Right? This could be 0. 0 times whatever gives me 0. Or this could be 0. Whatever times 0, that would be 0. So what we do in this case is we do the breakout kind of method again. Set the first one equal to 0 and the second one equal to 0. And solve both. Plus 3 I need to do here. So x equals 3, or minus 7 we need to do here. So x equals negative 7. So x equals 3 and negative 7. You have an application problem on there. I'm not as concerned that you do those word problems in this section. I just want you to practice the solving. And the two examples that you have for a practice problem are already factor. Oh, but they have equal 14 over here. Not so good. Not so good. So what do we do in that case? We got to get it to this form. We have to multiply this out. X times x for x squared, x times -5 for minus 5x equals 14, and then move the 14 over. Now we're kind of at matching this stage. X squared minus 5x minus 14, and we factor. 1 times -14, need to add to -5. 2 and 7 I can think of. If I put the negative there, then I add to -5. So I've got my factors. +2 minus 7 equals 0. You break these off and solve each one individually. So add 7 for x equals 7 there, and subtract 2 for x equals -2 here. X equals -2 and +7. Very similar structure, but kind of a different starting point. This was step 2 of that problem. We had to distribute this before we could move this number over and then be working with something that looks like that. That equals 0. Second example, a practice problem from 8.5 says x plus 1 times x minus 4 is equal to 14. We don't have 0 over there yet, so we can't use this as is. So that's a little frustrating, I know, but we can handle it by doing FOIL first. X times x for x squared. Outer, these two, x times -4 for -4x. Inner, these two, 1 times x for 1x. And last would be 1 times -4 and -4. So all of that gave us x squared minus 4x plus x minus 4 equals what we had over here, 14. We FOILed all this out and got that. Now, we got to move this 14 over. So subtract 14 on both sides. So that we have 0 over here. I'm going to go ahead and do some combining over here. This and this combine for -3 on the x term. -4x plus 1x is -3. And then these two can be combined for -18. Now we're looking to factor this. So 1 times -18. Its factors need to add to -3. I know 3 times 6 gives me 18. It looks like I'm setting myself up so long as I have the right difference, and that means negative here. Okay. Finally, x plus this and x is this minus 6 equals 0. Break off x plus 3 and x minus 6, both equal to 0. And then solve those. Minus 3 on both sides here gives me negative 3 plus 6 both sides here gives me x is 6. So it can be either negative 3 or positive 6. Do you believe that? Let's do a little further. So we got the answer. You could stop here, but let's just make a case for believing what we just did to be true. So either of these two numbers should work in the original equation, is the idea. So if I use negative 3, then I'd say negative 3 plus 1 times negative 3 minus 4 should give me 14. See how I plugged in negative 3 into these two places? So let's work it out. This works out to negative 2, this to negative 7. Is negative 2 times negative 7 14? Yep, that worked. So I'm a half a believer so far. Got this one. X equals 6. What do I get? 6 plus 1 times 6 minus 4. Does that give me 14? It's 7 here, 2 here. Looks like that checks out too. So there is that kind of checking that you could do after you come up with what you find here to be the solutions, just as a fallback and confident that you have the right solution. Now, in the interest of time, a lot of times on tests, you might choose to forgo doing that, right? It's a good habit to build confidence, to confirm your answers as you're doing your homework and practicing. I would say by test time, you probably, unless you found yourself with a lot of extra time after completing your test, maybe confirming one of these, or just having built enough confidence in your methods to where you don't have to check them when you're doing the test. Okay? That's my advice. Some people find that they get quick enough that they can do the solving and the checking all during the test time. Just be mindful of those things. Use this as a helpful tool as you are developing your skill and confidence in the methods. And maybe by test time, you're so skilled over here that you don't really need to do this for every item on the test. Okay. Just some food for thought. Was a recording now.